Hello everyone, good morning. Today we are going to see how to create your first database and schema. Creating your first database and schema. So what you are going to learn in this session, we will learn how to create a database and schema using the SQL. Understand the difference between them and practice with the simple commands. This will help you get started with a structured data storage and organization. So what are the Snowflake commands we are going to use to create a single database and single schema in the Snowflake database? So in this, you will be understanding the structure when you are going to write the simple commands. And also you will understand how it is getting, the data storage is getting organized and how it is well structured. Database. It is a logical container that stores related data. Think of it as a digital filing cabinet. It holds tables, schemas, and other database objects. It is a logical container. Logical container means it is going to store the tables in the form of rows and columns. It is going to have the schemas where you are going to have the tables and other database objects like whatever the tables going to have, primary key, foreign key, relationships, those things. So it is a container that stores the related data. So it has to hold the tables, schemas, and other database objects. A schema is a logical structure within the database that organizes the data into groups. For example, a logical structure means it is going to have student table, teacher table, master table, employee table, department table. So it is a logical structure within the database that organizes the data into groups. So students' records will go to the student table. Employee records will go to the employee table. Department records will go to the department table. This is the way how we are going to organize the logical structure, that is schema. It is like having the separate folders within your cabinet for different types of files, example HR, sales and finance. For example, in your organization, you are going to have the physical shelf where in the first level you are going to store the HR files. Second level you are going to store the employee files. The third level you are going to store the finance files. The same way how you are going to organize the tables in the schema. So database is a logical or the physical storage, that is a container which is going to store all these objects, schema, tables, constraints, primary keys, those. But schema is a logical structure which is going to have the table, which is the combination of rows and columns, and it is going to store the tables of different types, tables of different relationships. Clear? It is going to organize the data into different groups. Employee is one group, student is one group, and master is one group, department is one group. Like that, with the different groups, it is going to store the data. It is like having the separate folders in your shelf for each departments. Why database and schema? To keep data organized and secure. I want to keep my data very much secure and organized so that no one should interrupt with the data. And it should be organized. Even if I want to see the for example, in a student table, I have some 1,000 records. So I want to see all the 1,000 records in the particular order so that if I give the particular record number, I should be able to see the data. So the employee table is having the 100 records. The 100 records should be organized and it will be stored secured. No unauthorized access should not access the data. For example, if I am going to have the 100 records, what is organized? There should not be the duplication of records. Each ID should be unique. They should be having some primary key. And this table should be connected to other table or not. So this is the way how you are going to keep the data organized, and secured means protecting the data from unauthorized access. To avoid naming conflicts between the tables, you cannot have the same table name. For example, employee table multiple times, student table multiple times. No, that will give you the duplication of the data. To control access and permissions, I should provide the access and permissions to the users who have the privileges to access the data. Who is going to have the privileges? For example, Ambika is a user, belongs to the developer role. Ramesh is a user, belongs to the developer role. Suresh is a user, belongs to the manager role. So only the developer will have the access to store the data in the database, whereas the manager role will be having to admin the overall see that how the database is getting maintained, how the data is getting organized. To control the access and permissions, each user will be provided with the roles and privileges so that they cannot access all the objects in the Snowflake. So using the roles and permissions only, they can do the appropriate task in the Snowflake database. To separate workloads, production versus development data. In the production, whatever the operations we are going to do, the same we will not be doing in the development. In the development, we will be doing the R&D research. You will modify the code, you will test the data. If the test is okay, then you are going to take the code for the production. But once the code moves to the production, you may not be in a position to change the code. So the production data are valid and it is for long time. And development data is for short time. You are going to do some development for your code and you are going to test the data. Once the development is done, that's all the data will be moved to the production. So development is short time and the production is long time. So the workloads for the production will be very high when compared to the development. How to create a database? Using the command create database followed by database name. Create command followed by the database keyword followed by the database name. This creates a new database called company_db in your schema. Database is the first thing you are going to create. So once created, you can switch it to using use company_db. So before creating the schema, the first object in the Snowflake data warehouse, we will be creating the database for our usage. So the command is create command followed by database followed by the database name. This creates a new database called company_db. Once it is created, you should be able to see this database object in the Snowflake. Once the database is created, you can switch it to this database using the command use keyword followed by the database name. Now, how to create a schema? Within a database, you can create multiple schemas to organize the data. Create schema HR, create schema sales. Hence, we are created two schemas now. HR for employee related data and sales for customer and transaction data. Schemas help separate logical data groups so that multiple teams or departments can work independently within the same database. For example, in this, the database what I had created is company_db. Under that I have created the two schemas, one is HR and another one is sales. HR is going to maintain the employee related data and sales is going to maintain the customer and transaction data. So many departments will be accessing this database and these schemas for their purpose. So multiple teams or departments can work independently within the same database and with this multiple schemas. For example, you have the team A, team B and team C. The team A will be able to access the database company_db and under that they will be working in sales schema. Team B will be accessing this company_database in that they will be working in the HR schema. And team C will be able to access the company_database and they will be able to access both HR and sales schema. Create tables inside the schemas. How am I going to create a tables inside the schemas? First, the object to be created is database, then the schemas, followed by the tables. Now, we have our own schemas. Let us create a table inside one of them. Create table HR.employees. HR is the schema and employees is the table name. So, it is going to have the 4 columns: employee ID, employee name, department and salary. So whenever you are going to create a table, it should be in the form of the rows and columns. So columns is the employee ID, employee name, department and the salary. And for this you will be inserting the data. Those are called the rows in the database. So this employee ID, I have to provide the data type for this employee ID. So employee ID takes the integer, employee name takes a var character of 50, department takes var character of 30 and salary takes a decimal. Float variable. Salary will be in the form of float. So employee ID, employee name, department and salary. These are the 4 columns with the integer var character of 50. It is going to have 50 characters. Var character supports a string data type. It is going to hold first 30 characters. Decimal is going to take float, that will take the decimal of 10.2, 10,2. So in this, employee ID is a primary key. So when I am going to decide this employee ID as a primary key, this primary key will be used as a foreign key in another relational table. And this primary key, declaring this as a primary key, you are not going to maintain the duplication of records in the database. So this is the syntax. Create is the keyword. Table is the object you are going to create. HR is the schema. Dot employee is the table name. Followed by open parenthesis. These 4 columns. Next followed by the data types. Next followed by the constraints. Primary key is the constraint. This is the way how we are going to create the table in the database. This command creates a table named employees inside the HR schema. The full reference name of the table is company_db.hr.employees. First database .schema.table. If I am going to refer this table, I have to give this full reference name. Means first is database name, dot followed by schema name, dot followed by the table name. This shows how database schema and table hierarchy works. Similarly, we can create a table inside the sales schema. Similarly, the same command you have to use. First, we created in the HR schema. Now, I am going to create the table inside the sales schema. Create table sales schema.customer. Customer is the table name. So, I am going to have the 3 columns: customer ID, customer name, city. Customer ID is the integer data type. Customer name is a string var character of 50 and city is a var character of 40. So, var character is the string, integer is the numeric. I am going to have the 3 columns: customer ID, customer name and city. The primary key is a constraint which will be used as a foreign key in the other relational table, and it helps us to maintain the uniqueness of the data. So this is the way how we are going to create the table, and now we have created the table in the next schema called sales. Now insert the data. Once the table is database is created, schema is created, table is created under the schema. Now I am going to insert the data into the tables. You can now insert a data using this hr.employees values of first row. This is the first row. For employee table, what are the columns I have? Employee ID, employee name, department and salary. So the first one is employee ID, next is employee name, third HR is department, and fourth 55,000 is a salary. So this is the first row I am going to insert into the employee table. Next is employee ID 2, Jane Smith is the employee name, finance is the department, and 65,000 is a salary. So this is the second row I am going to insert into the employee table. Now insert into the sales table. But whatever you have inserted so far, it is for the employee table. In the third line, I am going to insert into the sales table. So insert into, this is the command you have to use to insert the data into the table. Insert into sales.hr, sales is the schema. Sales.customer table, values of open parenthesis. So what are the sales ID, customer name and city. Customer ID is 101, customer name is Alice and city is Newark. Last command is insert into again the sales schema, customer table, values of 102 is the customer ID, Bob is the customer name and Los Angeles is the city. So these are the way how we are going to insert the data into the table. Once you have inserted this data, when you are going to see into the Snowflake data warehouse, these tables will be having the records. Employee table will be having the 2 records and sales table will be having 2 records. So now verify the data. Select star from hr.employees, select star from sales.customers. So in the hr.employees, I am going to have the, so in this HR schema, I am going to see all the data from the employee table. Similarly, in the sales schema, from the customer table, I am able to see all the records. So this is the way I am going to verify the data. Now manage and drop schema. So once the job is done with the schema, I have created the table, I have inserted the records, I have retrieved the records from the database. Now I am going to manage and drop schemas. If I want to drop the schema, drop schema HR cascade. If I'm going to give the keyword cascade, the cascade keyword deletes all the dependent objects like tables inside the schema. The cascade keyword deletes all the dependent objects like tables inside the schema. Whatever the tables I'm going to have, everything will be deleted. It deletes all the objects at a time. To remove the entire database, I have to give drop database name. First, drop schema means it is going to drop the schema HR cascade. Cascade is going to delete all the dependent objects like tables inside the schema. If I want to delete the entire database, I have to give drop database name. So this is the way how we are going to manage and drop the schemas and database in the Snowflake data warehouse. In the real world example, in a real-time company database, you might have sales schema for sales data, inventory schema for product stock, HR schema for the employee records, all under the one master database like retail_DB. This structure allows different teams to manage their data independently while keeping them in the one place. So, in the retail_DB database, you are going to have the three schemas. One is sales schema, inventory schema, and HR schema. So different departments or different teams will be accessing each schema from this database or all the schema at a time from this database. Once they have created the tables and their job is done, they may be in a position to drop the schema from this database. So this is a real world example. Organized data management. This is why we are going for a database. Easier access control and security. Unauthorized access cannot access the database, and we will be provided with the easier access control. So every user will be provided with the roles and privileges to access the database objects and reduced confusions across the teams. Under the database, you have the different schemas. Under that only you are going to store the tables. So this unnecessary confusion will be avoided when multiple users are going to access the schema. Logical separation of data domains, that is called schema. Simplified data backup and recovery. So you can take the entire backup of the database, schema, tables, everything, so that you will be having the entire database backup and recovery for the whatever the tables you have created so far under the schema in the particular database. I hope this session feels interesting, and if you have any queries regarding this session or any queries for the upgraded content, please post your queries and enquiries in this below link under this description link. Thank you all.